Hello everyone. We are going to move to section 3.2, the law of sines. Before we start working with the law of sines, let's show what triangles we are going to deal with. We're not going to deal anymore with triangles with 90 degrees angles, so right triangles. We're not going to deal with them anymore. We are going to deal with oblique triangles. Oblique triangles do not have any of their angles equals to 90 degrees. So first, let's label the triangle the way we are going to label it in this section. So first, we're going to label the sides. Side A, side B, and side C. They are going to be lowercase ABC letters. Now we are going to label angles of the triangle. We are going to label angles with corresponding letter across the side. For example, this is side A. I'm going to label the angle across it, the angle A. I'm going to use capital letters for angles. Well, across B, angle B, and across C, angle C. So what is law of sines? It's a theorem which connects angles, or better say sines of these angles, and the sides into one nice statement. Theorem. The theorem is going to sound like this. Sine of A over A equals sine of B over B equals sine of C over C, where top ABC are angles and the bottom ABC are the sides. How I'm going to prove this theorem? Well, I'm going to prove only like this side of the statement. The other side can be proved like just like a similar way. So what I'm going to do in this triangle, I'm going to draw the height H. And this height H is dividing a big triangle like this, into two smaller triangles, like 1 and 2. I'm going to draw this first smaller triangle, which is going to look like this. Angle B here, side A here, and the height over here. Well, you know that from previous section, sine of angle B equals opposite side, which is H, divided over hypotenuse, which is A. H over A. If I solve this for H, for the top, I'm going to get that H equals A sine of B. Now I'm going to consider my second triangle, this one. And the second triangle is going to look like this, right? There's going to be angle A here, the same H, because that's the same side over here, right? And the side B. So I'm going to do the same operation. I'm going to write down sine of angle A equals the height, which is going to be opposite side, over the hypotenuse, which is side B. From where H is going to be equal B sine of A. Because it's the same H for like both triangles, they share the same H. I'm going to write down that A sine of B and B sine of A are equal. A sine of B equals B sine of A. What I'm going to do with this statement, I'm going to divide it over product of A multiplied by B. A multiplied by B. So here A cancels, here B cancels. And what we have as a result is sine of B divided over B equals sine of A divided over A. So I proved the first part of my theorem. The second part of the theorem, that this part is equal to this, proved the same way, just instead of drawing the height on the side C, we are going to draw the height on the side A. Okay, so the theorem is proved and we can use it to solve problems. I'm going to write down how the second part of the theorem is going to look. The second part of the theorem is going to look like this. Sine of B over B equals sine of C over C. And because sine of B over B is same here and here, means that we are going to write down sine of A over here. So we proved the law of sines. Okay, now the question is, how do we use it? How to use it? We're going to use it to solve triangles. Let me move to the next page. We're going to start with case 1. Case 1. And case 1 is going to be a triangle looking like this. Side C is given, and the angles B and A are given. You see that we have the side and 2 angles which stick to this side. To solve triangle means to find whatever is remaining unknown. For example, what is unknown here? It's side A is unknown, side B is unknown, and also angle C is unknown. We are going to start with the simplest, usually finding the angle, and then use a theorem to find sides A and B. Let's consider a specific example. Example 1. A equals 35 degrees, B equals 15 degrees, and C equals 5, let's say centimeters. Can be any 5 units, right? First, we remember that sum of angles of the triangle is equal to 180 degrees. So A plus B plus C equals to 180. From where we always can find C as 180 minus A minus B. In our case, it's 180 minus 35 minus 15, and that's going to be equal to 130 degrees. So we already found the angle. Now we just need to find 2 sides, A and B. How are we going to do it? We're going to use a theorem. Theorem is connecting A, B, and C with angles. I'm going to use just half of the theorem. I'm going to write down that sine of A over A equals sine of C over C. Why I'm using this part of the theorem? Because I actually do know the side C, it's 5, right? And I do know angles A and B. So basically the only unknown thing, and angle C also, and only unknown thing is going to be A here. Everything else is known. I'm going to just plug in the numbers, which I know already. So that's a sine of 35 degrees over unknown side A, sine of 130 degrees over side C. You see? Well, I'm going to do it once, but I'm hoping that for the rest of the problems like this, you can do it on your own. So how do we find A from here? Well, I think what we can do, we can flip over these 2 fractions, write down A over sine of 35 degrees equals, sorry, let me take a eraser. Sine is going to be in the denominator. And then go back to draw. That's 5 over sine of 130 degrees. Multiplying by sine of 35 degrees, I'm going to get A. A equals 5 sine of 35 degrees over sine of 130 degrees, which is going to give me the number around 3.7. So I found my first side. I'm going to repeat this operation with side B. I'm going to write down sine of B over B equals sine of C over C, which is going to give me what? Sine, my angle B is 15 degrees. My side B is unknown, and my C is going to have same dimensions. So it's going to be sine of 130 degrees over 5. I'm going to jump to B right away. That's 1 sine of 15 degrees or sine of 130 degrees, which is going to give me approximately 1.7. Usually, guys, I would like you to round up the numbers for sides and keep one digit after decimal point. And for angles, you can round everything up to the whole amount of degrees. I'm going to be okay with this. Okay, so answer for this question is that side A equals 3.7, side B equals 1.7, and angle C equals 130 degrees. So we are done with our first problem. Let's move to the second problem. I'm going to move to the next page. Case 2. We're still going to work with 2 angles given and 1 side, but angles are not going to be sticking to the side which is given anymore. So I'm going to have side A over here given, and two angles B and A given. You see the difference between case 1 or the previous one. Before we had angles given next to the side, and it was easy to manage after this point. Right here we have angles, one angle is adjacent to the side and one angle is opposite. What we'll need to find? We'll need to find side C, side B, all right? And angle C is a question too. Well, as usually, we are going to start with angles. If you do know two angles, angle number 3 is easy to find. We already kind of know that it's 180 minus A minus B, and we are just going to use the numbers given. Let's consider numbers like this. A equals 4, the angle A equals 40 degrees, and angle B equals 60 degrees, okay? So first we're going to find angle C, and that's gonna be 180 minus 40 degrees minus 60 degrees, and that's going to give us 80 degrees, right? From this point, we are going to reduce our case to case number 1 because we have two angles adjacent to the side, and we just need to find two sides, right? Well, before we had side C given, now we have side A given, but it's not going to kind of change a lot, right? So just one side of your theorem is supposed to be everything known, another side is supposed to have one unknown. I'm going to start with sine of A divided over A equals, for example, sine of B divided over B, right? And because we don't know B, I'm going to plug everything in except B. So A is equal 40, so sine of 40 degrees over the side A, which is 4, equals sine, and the angle B equals 60 degrees over unknown B. Well, I'm just going to write down solution for B without like doing all the math on it because it's just easy. You can do it anyway. You can flip it over and then write it down, or you can rewrite it some way. Let me just write down the final answer. 4 sine of 60 degrees over sine of 40 degrees. And if you use your calculator for all these signs, don't forget to use degrees, not radians. You're going to find that it's approximately 5.4. Well, same way we're going to find sine C. We're going to write down sine A over B equals sine C over C, which is going to give us sine of 40 degrees over 4 equals sine of 80 degrees over unknown side C, over C is going to be equal 4 sine of 80 degrees over sine of 40 degrees, which is going to be equal to 6.1 approximately. So the answer for this question is angle C 80 degrees, sides B equals 5.4 and C equals 6.1. Okay, so there were cases 1 and 2. In the book they call it case 1 because actually what we have given is one side and two angles, SAA, one side and two angles. And actually it's not important in which order angles are given. You remember, if you do know two angles, you always can calculate angle number 3. So actually that's one side and three angles. And that's why they unified into one case. Now, what other cases we are going to have? Let's move. Well, they're not allowing us to use more pages, I guess. What I'm going to do, maybe I'm going to just move, shift it up. No, doesn't work actually. What is it? No, doesn't work. Well, okay, I'm going to erase case 2. I think everyone did copy case 2. I'm going to put my notes on line 2, so you're going to see all the cases. So let me erase case 2. Where is my eraser? Eraser. Well, maybe I have clear all drawings. Ah, very fast, right? Okay, we're going to move to case 3. Case 3 is going to be is going to happen when somebody gives you two sides, side B and side A, and one angle, something like this. How this case is different? Well, guys, normally, how do we build a triangle if somebody gives us these numbers? Usually, we are going to draw a straight line like this. That's going to be the base. We don't know how long is this side, so we're not going to limit it somewhere, but we know that it's going to start somewhere, right? We don't know where it's going to end. We're going to, after, take a protractor. Remember, protractor is device looking like this. And measure angle A with protractor, and we can draw a line under this angle, so angle A. Then, sorry, my A doesn't look very nice. Let me erase it and draw a new one. Then we're going to take a ruler and measure the length of side B. Well, somebody is going to give us, how long is this, like 5 centimeters or 10 centimeters. We're going to measure it, and for example, it ends over here. Now we need to draw side A somehow, but because we don't know this angle, we don't know where to draw side A. What we are going to do, we are going to take a compass. Remember, compass is something like this. Something like this. One side is a needle and one side is something like a pencil. We're going to make the size of this compass equals to A. And we will try to draw a circle from this point. Circle around this point. Interestingly, depending on A, this circle can look differently. I'm going to draw 3 different circles to show you possible differences between, let me see if I choose a color. It doesn't look like I can choose a color. Well, okay, I'm just going to draw black circles. Doesn't look like I can choose a color. Maybe my pencil pen is going to allow me to choose the color. Yeah. Okay. I think it's gonna be allow me to draw a circle. No? Okay, not the best circle I can see, but if I shift it a little bit, trying to move it actually along in the center of the circle. Well, it doesn't look like I can move it. It would be better if I just draw a circle manually, I guess. Okay, well, I'm just going to draw manual circle. So what kind of circles we can have for side A? Well, first, it can be a tiny little circle like this. Second, it can be a bigger circle like this. And third, it can be even bigger circle like that. What the circles are going to do? Well, guys, if your side A is too small, circle is going to be like this, and it's never going to intersect actually this base. Means that triangle with this side is not going to exist because side A is too short. It's not going to kind of touch side C. So there's going to be no triangle if your A is too short. Well, how short it's going to be to not touch? Well, to touch actually, it's supposed to be as long as this. This is the height, right? If you draw this triangle, what is height? Height of this triangle, H, you already know, is going to be B sine of A. So actually, if A is less than B sine of A, we're going to have no triangle. Well, too bad, but that's going to be the answer, and you don't need to do anything after that. What is going to happen if it's like bigger, if the A, the radius of the circle, is bigger than B sine of A? Well, it's going to have 2 intersections, one intersection here and one intersection here. For us, it's going to mean that we can build 2 possible triangles, one triangle with this side and one triangle with this side. They are both going to satisfy our conditions of the angle A, side B, and side A. I'm going to write it down. So if B sine of A is less than A, it's going to be 2 triangles. How far we are going to have 2 triangles? Well, if the radius or the side A is medium, we are going to have 2 triangles. But you see, if we start increasing it, make it bigger. Eventually, it's going to be bigger than side B. And the circle is going to pass on this side. It's not going to make up a second triangle. And we are going to have only one triangle. So the condition for two triangles is still less than B. Two triangles. Okay? And when A is greater than B, we're going to have the biggest circle. And that's going to be just one triangle. Okay? So these are going to be conditions. Usually, guys, we're supposed to check these conditions before we solve the problem on case 3. Otherwise, we don't know like how many solutions we have to give. I'm going to give examples of all 3 cases, like to short side, medium side, and long side, and they are going to result in different number of triangles. So I'm going to start with example 1. Example 1 is side B equals 2, side A equals 1, and angle A equals 50 degrees. I'm going to start with checking B sine of A, the height. What is the height? Height, which is B sine of A, is going to be 2 sine of 50 degrees. And it's going to be around 1.5. Well, you see that 1.5 is greater than this side A. We are going to have a case when the circle is never going to touch the base. So here the answer is no triangle, because 1.5 is greater than A. This one is greater than A. Okay, no triangle. Example number 2, same B. I'm going to choose a bigger A. Well, I see that condition is 1.5, right? Which is not going to touch. Actually, when it's exactly 1.5, it's going to touch at one point and we're going to have right triangle. But because we solved right triangles in the previous section, we're not going to deal with them anymore, okay? So let's choose a number which is greater than 1.5, but not greater than B, not greater than 2. I'm choosing number 1.6. I'm not super creative. 1.6 is greater than 1.5. On the other hand, it's not too big to go around this side, not longer than B. B is equal to 2. So I'm going to have 2 triangles. So how do we find these 2 triangles? From where the insolutions are going to appear? Well, I'm going to start using sine's theorem and put all the numbers together. I'm going to write down sine of B over B equals sine of A over A. From where I can plug in my numbers. Sine of B over 2, my B is equal to 2, sine of 50 degrees over 1.6. Plugged in the numbers, from where I'm going to get a sine of B equals 0.94. I just use my calculator. And you know that usually when the sine of something equals to a certain number, there are 2 possible angles which correspond to this. 94. Imagine that this is 0.94. We remember that sine is y coordinate, right? So going to be 2 angles, angle 1 and angle 2. First angle we can get by taking sine inverse of 0.94, and that's going to be equal 70 degrees. For the second angle, we know that this one is 70 degrees, this one is 70 degrees. So we are going to find out that it's 180 minus 70 degrees, and that's going to be 110. So this angle is going to be kind of B1, and this one is going to be B2. So these 2 angles are going to produce 2 different triangles. Like this one was 110. 110 is obtuse angle. And this one was 70 degrees, which is going to be this one. Okay? Now what we need to do, we need to calculate the rest. The rest is angle C and side C. Well, I'll try to squeeze everything. Maybe I should move this thingy over here and I can use the space. Okay, I'm going to use this space to calculate the rest. So I'm going to start with angle C1. Angle C1 is going to be 180 degrees minus angle A minus angle B1, which is going to be 180 minus 50 minus 70, and that's going to be 60 degrees. Using sine's theorem, I'm going to find that side C is A, sine of C or sine of A. You guys can do the proportion yourself, right? It's going to be 1.6 sine of 60 degrees divided of sine of 50 degrees, which is going to give me 1.8, approximately, of course. C2, the angle C2, it's 180 minus A minus B2, and that's going to be 180 minus 50 minus 110. That's going to be 20 degrees, which is going to give me side C. The same formula, you just plug in different angles C. Instead of 60, you plug in 20. So it's 1.6 sine of 20 degrees over sine of 50 degrees, and you are going to get 0.71. So we calculated everything. The only last thing I'll need to do is to write down the final answer for this. Let me see what this is going to be. The final answer, oh, they gave me a new page. The final answer over here is going to be two triangles. C equals 1 point A, big angle C equals 60 degrees, angle B equals 70 degrees. And second triangle C equals 0.71, the angle C equals 20 degrees, and the angle B equals 110 degrees. So that's the first triangle, and that's a second triangle. Okay, so answer is going to consist out of two triangles. Well, if we keep increasing side A and make it bigger than side B, we're going to get example 3. B equals 2, A equals, well, let's just take a simple number 3. It's greater than B. We're going to have just one triangle. I'm keeping the rest of the numbers same. I'm going to draw how this one triangle is going to look. So that's B equals 2. That's A equals 3. And if you draw a circle will go like this. So it's not going to intersect the line twice over here. And the 50 degrees, right? So, well, again, I'm going to use a theorem. I know already that it's one triangle because B is greater, is less. Let me take and B is less than A. We know that 2 is less than 3. One triangle, one. So I'm going to write down that sine of A over A equals sine of B over B, from where, maybe that's very good, from where sine of 50 degrees equals sine of B over 2. This is A, this is B, this is known sine, that's unknown. From where sine of B equals 2 sine of 50 degrees over 3, which is 0.51 approximately, from where B, the angle, is sine inverse of 0.51, which is approximately 31 degrees. Very good. Now we can find the angle C, the third angle remaining. It's 180 minus A minus B, and that's going to be 180 minus 50 minus 31. That's going to be 99 degrees. And the remaining side, sine of A over A equals sine of C over C, from where C equals A, sine of C over sine of A, which is going to be 3 sine of 99 degrees over sine of 50 degrees, which is approximately 3.9. So the answer is going to be B equals 31 degrees, C equals 99 degrees, and the sine C is 3.9. So we solved the problem. Right. Well, I'm going to remind you how conditions of 1, 0, and 2 triangles are going to look. So how to know 0, 1, or 2 triangles. Let me move this thing over here. So 0 triangles happens when A is less than B sine of A, right? I'm going to write down A is too short. 0 triangles. 1 triangle happens when A is greater than B. A is too long. 2 triangles happen when A is in between these two conditions. So A is greater than B sine of A, less than B. A is median. And we have 2 triangles. Okay? Now, I want you to solve one problem on your own self. And you can stop the video and try the problem on your own and then check my solution. I'm going to, of course, provide solution. So right now I'm going to count 1, 2, 3. You can stop the video and then start it again. So my first question is how many? Well, B sine of A is equal 8 sine of 35 degrees, which is 4.5. Well, it's less than A, which is equal to 6, right? But on the other hand, A is less than B, which is equal to 8. So we do have this case. B sine is less than A, but B, the side B is greater. So A is medium, 2 triangles. Conclusion, 2 triangles. 2 triangles is the longest case, and I'm going to start solving it. So sine of A over A, sine of B over B, from where sine of B equals, I'm going to plug in the numbers. A is equal 8, 6, sine of 35 degrees, which is going to give me approximately 0.76, from where B, which is sine inverse of 0.76, is going to be equal 49 degrees approximately, maybe 48, but somewhere around. Well, I remember that, sorry, switched my whiteboard, pressed something accidentally. So that's going to be one angle B. And second angle B, very simple. You don't need to draw a triangle actually. Second angle B is 180 minus first angle B, minus 49 degrees, which is going to give me 139 degrees. Now I'm ready to finish solution. So first triangle C1, the angle C1 equals 180 degrees minus B1 minus A equals 180 minus 49 minus 35 equals 96 degrees. Using sine's theorem, we can have sine of C1 over C1 equals sine of A over A, from where C1 equals A sine of C1 divided over sine of A, which is going to be 6 sine of 96 degrees divided over sine of 35 degrees, which is approximately 10.4. We'll have room below. Second triangle. For second triangle, C2 equals 180 minus B2 minus A, which is going to give me 180 minus 131 minus 35 equals 14 degrees, a very small angle. And C2, the side C2 is 6 sine of 14 degrees, sine of 35 degrees, and equals approximately 2.5. If you compare these two formulas, you're going to see they're pretty much same, right? The sine of 35, same, 6 is same. The only sign of C is going to change to 14 degrees or 96. Okay. So what is going to be next? Well, next I'm going to just write down the final answer. Let me erase my, let me erase this part and just finish with the answer. So first, triangle B equals 49 degrees, C equals 10.4, and angle C equals 96 degrees. Second, triangle B equals 131 degrees, side equals 2.5, and the angle equals 14 degrees. You can arrange them in like different way if you wish. Okay, I think that's going to be all for this lecture. Do your homework, and this is last section included in midterm exam. Okay, I placed review for midterm exams so you can actually go over it.